Okay, in this problem, it says a light signal is sent from the origin of a system K at t equal to 0 to the point x equal to 3 meters, y equal to 5 meters, and z equal to 10 meters. At what time is the signal received? And then find x prime, y prime, z prime, and t prime for the receipt of a signal in a frame k prime that is moving along the x-axis of k at speed of 0.8 c. From your results, verify that the light traveled with the speed c as measured in the k prime frame. All right, so let's do part A first. So here is frame k, x, y, z, and you're sending a light signal from the origin to the point x equal to 3, y equal to 5, z equal to 10. So to there. Okay, that's 3, 5, 10. So the distance to that point is 3 square plus 5 square plus 10 square. Okay, let me write it as x square plus y square plus z square is equal to 3 square plus 5 square plus 10 square, and that distance is equal to 9,134. It's 11.6 meters. Okay, so and distance, so speed will get there at time t equal to d over c, which is 11.6 meters divided by 3 into 10 to the power 8 meters per second. All right, so which is the speed of light. And so the light signal sent at t equal to 0 will get there at 3.86 times 10 to the minus 8 seconds later at that time. All right, so now in part B, what we want to find is, so if we have a k prime and k prime is moving at along the x-axis at speed of 0.8 c. Okay, so what are the coordinates of what are these coordinates in the k prime frame? And you can check the Lorentz transformation in your notes. So the Lorentz transformation are given by x prime equal to x minus vt divided by 1 minus v square c square. Y prime is y, z prime is z, and t prime is t minus vx over c square and 1 minus v square by c square. All right, so let's calculate these guys. Let's add a page. Okay, first let's calculate this factor. 1 minus v square by c square is equal to v, the v is 0.8 c divided by c square. So that's v square by c square, and so that's equal to 1 minus 0.8 square, and this is equal to and so this is 0.6. Yeah, so that's 0.64, 0.36, yep, 0.6. All right, so we have that factor. So let's calculate x prime. X prime is x minus vt divided by 0.6. X is 3 meters, v is 0.8 c, and t, the time at which the signal reaches that point, is 3.86 times 10 to the minus 8 seconds. 3.8 to 10 to the minus 8 seconds divided by 0.6. So, and this is equal to, all right, so 3 minus 0.8 c is 3 times 10 to the 8 meters per second, and into 3.86 into 10 minus 8 seconds divided by 0.6. And this will work out to, this 10 to the 8 cancels that, so it's 0.8 times 3 times 3.86. Anyway, so this will work out to minus 10.4 meters. Okay, so x prime, so the coordinate, so what we are calculating is, in the K frame, you sent out a light signal to that point, and when the light signal reaches there in K prime, that event is at, the x coordinate of that event is minus 10.4 meters. Okay, so that's what that is. And of course, y prime is equal to y, which is 5 meters. Z prime is equal to z, which is 10 meters. And now we have to calculate t prime. And t prime is, I guess, okay, let's add another page. We'll so t prime is given by t minus vx over c square, vx over c square divided by 1 minus v square by c square. All right, so in the unprimed frame, the event happened at 3.86 times 10 minus 8 seconds. Minus v is 0.8 c, x is 3 meters, and c squared divided by, this factor is 0.6, so 0.6. All right, one of the c's cancels, so we have 3.86 into 10 minus 8 minus 0.8 into 3 divided by 3 into 10 to the power 8 meters per second. So the second will come to the top, the 3 cancels, divided by 0.6. And so this works out to 3. Okay, I'll do it in 2 steps. Minus 0.8 into 10 minus 8 divided by 0.6 seconds. And this is equal to 3.06. Oops, that's a minus 8. Okay. This is 5.1 into 10 minus 8 seconds. So in the K prime frame, okay, so when this light signal reaches there in the K frame, that light signal reaches there at 3.86 times 10 minus 8 seconds. When the signal reaches there, an observer in this frame sees it reaching there at 5.1 times 10 minus 8 seconds. So a little later. Okay. All right, so we've calculated that, and now for the last bar, we want to calculate the speed of light as seen by the K prime frame. So for the K prime frame, in the K prime frame, the coordinates x prime, y prime, z prime, and t prime are, for this event, are minus 10.4 meters, minus 10.4 meters, 5 meters, 10 meters, and the light signal arrives at 5.1 times 10 minus 8 seconds. Okay. So now the question is the speed of light equal to 10 to the power 3 times 10 to the 8 meters per second? Okay, so let's calculate the distance d prime to that point, which is x prime square plus y prime square plus z prime square. And so this is equal to minus 10.4 square plus 5 square plus 10 square equal to and this works out to 15.3 meters. Okay. And so let's calculate d prime over t prime. That should be the velocity of that light signal, and that's equal to 15.3 meters divided by 5.1 into 10 minus 8 seconds. And so this is 3 times 10 to the 8 meters per second. All right, so the speed of light is the same in all frames of reference. That's what we've verified. Okay, that finishes that problem.